Hello and welcome to another video. Today we'll be looking at variable acceleration mechanics from the year 1 textbook Edexcel. So let's get into it. So first we'll be defining what variable acceleration is. We'll be looking at the how we can find maximum displacement from a starting point, maximum and minimum, we can find the maximum velocity and maximum displacement, and then we'll be looking at integrating, which ties back into the last video's topic of integration, and we'll be using integration here to find the displacement of an object using a velocity time graph. So first we'll start with some basic knowledge. So when we're looking at variable acceleration, we're going to be looking at graphs that look like this, where the velocity is constantly changing and the acceleration is also constantly changing. So where before we had constant acceleration, where although the velocity was also constantly increasing, the rate at which it was increasing was constant. So we had constant acceleration and constant deceleration, which is what this little graph here shows. And in a velocity time graph, when it's just a straight line, that means that there's no change in velocity, therefore there's no acceleration. So that's what usually where you'd find an object accelerating. That's what the graph should. You would expect the graph to sort of curve upwards for a velocity time graph, and when it's decelerating, you expect it to curve downwards as the change in velocity is decreasing. Okay, so we know that in a velocity time graph, the gradient of this graph is going to be the change in y over the change in x, and our y value is v and our x value is t, which means that the change in velocity over the change in time, that equals to acceleration, which means that to find the acceleration from a velocity time graph, we can use the gradient function to find the acceleration. And this is where we get acceleration equals dv over dt, and because we know that displacement equals to so because we know that displacement is also a function of velocity, we can also write this as a equals d squared s over dt, and we know that velocity equals ds over dt. And one way we can remember this is that we know that speed equals distance over time, or velocity equals displacement over time. So this is how we can remember this. Okay, now we're looking at maximum and minimum. So we know from pure maths that we can find the maximum and minimum using the gradient function. So when the gradient is 0, we can find our maximum and our minimum. So here, this point here is where the gradient is 0, and this point here is also where the gradient is 0. And we notice that this is our maximum displacement and this is our minimum displacement. Okay, now we notice that when we have a displacement time graph, if we have an equation like this, we can rewrite it as displacement equals t to the power of 4 over 50 minus 12t cubed over 50 plus 28t squared over 50 plus 8. And we notice that our constant 8 here is what displacement starts off at. So here in this question we have a drone, and we're asked to find the maximum and minimum displacement. Okay, so essentially what this graph is telling us is that the drone essentially started off at 8 meters from the ground and started moving up, and then it started moving down below where it started from 8 meters off the ground. And because it never touches the x-axis, we can assume that it just doesn't land. Okay, so to find the maximum and minimum from this graph, we can do ds over dt, which gives us 4t to the power of 3 over 50 minus 336t squared over 50 plus 56t over 50. Okay, and then when we equate this to 0, okay, because remember if the gradient here is 0, that means that ds over dt equals 0, so that means that this also equals to 0. We get the values that t equals to 7, t equals to 2, and t equals to 0. Okay, so t equals 2, that references this point in the graph, and t equals 7 references this point in the graph. Okay, so we can see that 2 is going to give us our maximum value, and 7 is going to give us our minimum value. So we substitute the time back into the equation, and if we do that, so that means that s equals to 2 to the power of 4 over 50 minus 12 times 2 to the power of 3 over 50 plus 28 times 2 squared over 50 plus 8, which means that our maximum displacement is 8.64 meters. Okay, and we can just repeat this process for our value of 7 seconds to get so where we have 2, we just substitute 7, and that will give us a value of 1.14 meters. Okay, now if we didn't have the graph and we wanted to sort of, if you just wanted to know what our maximum and minimum values were, we could differentiate again. Okay, so which would give us 12t squared over 50 minus 72t over 50, and because I'm running out of space here, it's just sort of plus 56 over 50 as well. Okay, so we then substitute 2 where t is. Okay, and then so when we do that, we get when we substitute 7 in, we get 2.8, and we substitute 2 in, we get minus 0.8. So we know that because this is less than 0, this is our maximum value, and because this is more than 0, that's our minimum value. Okay, so now let's look at integration. So when we integrate for the area of a velocity time graph, we can find the displacement of an object. Okay, so we know that when we have, say, let's just draw a velocity time graph. If we have a constant velocity and it's going at 8 meters per second for 6 seconds, okay, so we know that speed equals distance over time, so that means that we can just do 8 divided by, we can do speed, because we know that speed equals distance over time, we can do velocity times by the time, which would be 8 times 6, or from the graph we can see that's just finding the area of the graph, 8 times 6. So essentially, when we're integrating, we're doing the same, but it's just simply a more accurate way of finding the total area from 1 to 3 in this time. Okay? And one thing you're gonna have to be aware of is that when we have a velocity time graph, when it goes from being when it goes from the positive y-axis to the negative part of the y-axis, that means that there's a change in direction, because velocity is a vector, which means that its magnitude in a given direction. So when it's going from a positive value to a negative value, it's essentially going in the opposite direction from where it started. Which means that if we want to find out the displacement of an object, what we want to do is we want to find the distance from a point. So if we get our plane back, okay, so let's say our plane starts off with a velocity of 3 meters per second and initial displacement of 0 from this point here. Now, according to the graph, it starts off with 3 meters per second, then it starts slowly decreasing, and then it changes direction, and then it goes like that, and then it keeps going in the opposite direction, and then it comes back a bit later on. Okay, so from the velocity time graph, we can see that when we need to integrate these parts separately as when we integrated in the last video, because the area here is going to give us a negative value and the area here is going to give us a positive value. And we can see that if we integrate from 0 to 1 here, which is, so that's the area equals to the integral to 1, okay, and that's just going to be x cubed minus 3x squared minus x plus 3 dx. Okay, that's going to give us sorry, it should be so if we integrate from 2 to 1, we'll get minus 7 over 4, and if we integrated from 1 to 0, we'd get 7 over 4. Okay, which means that if we add these together, we get a displacement of 0 meters, right? And we can see that when we draw the displacement time graph for the equation here that we have for velocity, we can see that at time t 2 seconds, the displacement is 0 again. Okay, so at time t 2 seconds, the displacement is 0, and that correlates with the graph here. So if we want to find the total distance traveled, okay, so the total distance, so not the plane going there and then also just coming back, we just want to find sort of separately it going here, it going here. Okay, so that would mean that we'd have to do minus 7 over 4 times by minus 1, which equals 7 over 4. We do 7 over 4 plus 7 over 4 to get a value of 14 over 4, or in other words, we get a total distance traveled of 7 over 2 meters. Okay, and that's variable acceleration. I hope you found this video useful. If you have any other topics you'd like me to go over, please you can request it in the comments and I'll be sure to have a look at it. If you haven't already, please subscribe and thank you for watching.